Remember, you take it as a note, very much important concepts. The order of reactivity of your respective alkyl halides towards the preparation of your Grignard reagent. ಯಾವುದು ತುಂಬಾನೇ ಬೇಗನೆ magnesium ಜೊತೆ in the presence of dry ether ಜೊತೆ react ಆಗಿ ನಿಮಗೆ Grignard reagent ಕೊಡುತ್ತಂದ್ರೆ the order of reactivity is in this way. First is your alkyl iodide, then comes your alkyl bromide, then comes our which one? Alkyl chloride. So whenever we are having all these three, the first will be reacting with your magnesium in the presence of dry ether is your iodide part, alkyl iodide. Then is your alkyl bromide, then is our alkyl chloride. Then the second most important thing we have to remember, as the number of the carbon atoms goes on increases in the alkyl group, as the number of the carbon atoms increases in the alkyl group, what happens? Lesser will be the reactivity. That is, in simple words, if I have to say, if you are having as a CH3I, CH3CH2I, and then afterwards I can write as CH3CH2CH2I. So among this one, which will be going to have the higher reactivity? Of course, for this. Why? Because it is having the less number of the carbon atoms in their alkyl halides. That is what it is saying. So as the number of the carbon atom increases, what happens in the alkyl group? Lesser will be the reactivity. So among these three, this will be having the lower reactivity for the formation of its respective Grignard reagent. And one of the most important and interesting point you just remember, whenever you are using your tertiary alkyl iodide, so they can't give you the Grignard reagent, very much important. Instead, they will be undergoing the elimination reaction to give our respective alkene. Okay, very much important. Once again, I am repeating. So whenever we are talking about a tertiary alkyl iodide, so whenever you are treating tertiary alkyl iodide in the presence of magnesium and a dry ether, instead of giving the Grignard reagent, what it is going to do, it will be undergoing an elimination reaction to give us as an alkene. Very much important. And as I have said earlier, what we can say, Grignard reagents are very reactive. So if any source of water, alcohol, or your primary or secondary amines, that is your NH2, amines are present, what it will be getting? We'll be getting our hydrocarbons. And that is the reason why we have to mention the dry medium has to be maintained, and more particularly dry ether is used in this overall preparation of your Grignard reagent. So these are certain additional information which could be useful when you are doing your competitive questions. Now coming to the most important and interesting thing is, of course, what we came to know. So whenever you are treating your alkyl halide with a magnesium powder in a dry ether, you are going to get your respective Grignard reagent. Now the question arises that whether all alkyl halides are able to give your Grignard reagents. I repeat the question, that all alkyl halides are able to give Grignard reagents. The answer is no. Once again, an important part you have to remember, make it as a note. It's only for additional information I am giving. Okay. So now we have to understand then which are the alkyl halides which are not able to give your Grignard reagents. Do remember, guys. First, you remember allyl and benzylic. Allylic and your benzylic halides. I repeat, allylic or your benzylic halides, when they are treated with a magnesium powder or a dry ether, they are not going to give our Grignard reagent. Similarly, second one you have to remember the part, for example, you are having in like this X, CH2, CH2, an acidic group. So whenever you are having an alkyl halide which is also attached to an acidic group, that acidic group could be your SO3H, or it could be some alcoholic group, or it could be also your carboxylic acid group. So all such groups, whenever it is present along with your alkyl halide, they will be also not be able to give your respective Grignard reagent. Third most important thing, remember, your vinylic halides. Vinylic halides will also not be able to give our Grignard reagent. Fourth one, which one? Yes, this one. Like this, whenever you are having, that is X and an X, that is 1,3 dihalides. 1,3 dihalides will also not be able to give our Grignard reagent. Then coming to that of your orthodihalides, ortho substituted dihalides. So in this case also they are not able to give our respective Grignard reagent. Then coming to another part, that is if you are having the system as in this way, CH2X, CH2, and here you are having some leaving group, a good leaving group. Yes. So in this case also what happens, you are not able to get your respective Grignard reagent. Why I am mentioning this? Because these are the 6 alkyl halides you have to remember. So in your option you are having these 6, any of the molecules, you should get to your brain what is that. Okay, these are the alkyl halides which are not able to give that of your Grignard reagents. Let me solve certain for you. For example, when I have chosen as an allylic halide, how it would be? Yes, so it will be in this way, CH2 double bond CH, then what you will be having, CH2X. So what happens when you are treating this one with your magnesium powder in a dry ether? What happens basically? First, importantly, they will be giving you what? CH2 double bond CH, CH2 MgX. Of course, they will give you. But whatever it has been formed, what it is highly unstable. So it is going to react with the one more molecule of your reactant, CH2 double bond CH single bond CH2X. So what it will try to do now, utilizing this carbanion, ಏನಾಗುತ್ತೆ MgX ಹೊರಗೋಗಕ್ಕೆ ಸ್ವಲ್ಪ ಚಾರ್ಜ್ ಸೆಪರೇಷನ್ ಇರುತ್ತೆ. ಸಾರಿ, ಐ ಮೀನ್ ಯಾವತ್ತೇ ನೀವು RMgX ಅಂತ ಬರೆದಾಗ ಇದು ಮೇಲೆ ಯಾವ ತರ ಚಾರ್ಜ್ ಇರುತ್ತೆ ಅಂದ್ರೆ delta minus, delta plus and a delta minus. Like this charge separation will be there, which indicates whatever the RMg bond is there, it is somewhat polar covalent bond. That is, it will be having certain percentage of your ionic character and also that of your covalent character. Nearly 52% of your ionic character will be present and nearly 48% of your covalent character is present. So therefore that is the reason they will be having certain charge separation. So what happens over here? So utilizing the negative charge on the alkyl group, it will try to once again react with that of your another mole of a reactant. Here X moves out and this X will be coming over here forming an MgX2. So you will be getting the final product instead of a Grignard reagent as how? CH, CH2, here also CH2, then you are going to get a CH double bond CH2. And it is called as your diallyle. So this is the reaction what you are going to take place when you are taking your allylic halides. Instead of forming the Grignard reagent, what it is trying to do, it is giving the final product as our diallyle. Coming to that of your benzylic now. Benzylic halides. So where will your benzylic halides will be? Yes, you will be having your benzene ring with a CH2 and an X. So when you are treating this one with your magnesium in the presence of our dry ether, what happens? Basically, first, once again the same protocol takes place, and instead of reacting, first it will be giving you as what? CH2 MgX first. And then what happens? Once again it is going to react with a one more mole of your reactant like this. So here you will be getting as CH2X. So you're using its carbanionic part, it is going to attack over here. So you're going to get your product as what? CH2 CH2 and over here like this, which is called as what? Dibenzyl. Which is called as what? Dibenzyl. Plus, as mentioned, MgX2 you are going to get. So instead of forming the respective Grignard reagent, whenever you are using your benzylic halide, what it is going to give? Dibenzyl. Similarly, in the case if I am going to choose as my vinyl halides, so how will your vinyl halides be? CH2. Yes, here if I am going to write as a Br, single bond CH2 Br. So when you're treating this one with a magnesium in the presence of dry ether, so what it will try to do is it will try to form an alkene instead of giving you the what? Grignard reagent. So that is the reason whenever you are having such vinylic halides, they will also not be able to give their Grignard reagents. Coming to the 1,3 dihalides. So what happens over here is generally the reaction will be in this way. Here you will be having your Br in the presence of Br plus magnesium in the presence of dry ether. A radical mechanism takes place, so there will be a tendency in such a way, the reaction is very good. First it will form a radical in this way. First MgBr2 you will be getting. So since what happens, this forms a closing of chain anta ಹೇಳ್ತೀವಿ. So this will closing of ring system. A ring ಏನಿರುತ್ತೆ close ಮಾಡಿ. So this will be our cyclopropane. Cyclopropane will be obtained. So that is the reason 1,3 alkyl halides, dialkyl halides are also not able to give our Grignard reagent. Then coming to the another part, that is if I am going to choose this part. So here you are having your Br and here you are having your Br. So when it is treated with a magnesium in the presence of our dry ether, remember, so what it is going to give is a benzene, remember. So you will be having here like this. Can you see? So this is also a structure. So this will not stop over here. Instead what it will try to do, once again it will react with a one more structure of the benzene. Yes, like this. So this bond goes over here, this bond. So final product you are going to get in this way. Like this. Sorry, here my bond is like this. So this is our final. So instead of giving the Grignard reagent, what is happening? So whenever you are having an ortho substituted, I repeat, whenever you are having an ortho substituted dialkyl halides, you will be getting this product instead of getting the Grignard reagent. But this is not applicable whenever you are having for your meta position or your para position. So when you are taking like this dialkyl halides, there is a possibility, so they will be giving you the respective Grignard reagent. But whenever you are having an ortho position, what it will trying to do, it is going to give as a benzene. Remember, very much important, where your benzene ring is having a triple bond character. Okay, very much important. And do remember, this is the only pi bond, alwa, this is the only pi bond which has been formed by using your sp2 hybridized orbitals. ಇಲ್ಲಿವರೆಗೂ ನಾವು ನೋಡಿದ್ವಿ pi bond ಆಗಬೇಕು ಅಂದ್ರೆ they are all formed by the overlapping your unhybridized pz orbital. But this is the one compound you have to remember where our pi bond is formed by the overlapping of the hybridized orbitals. I repeat, by the overlapping of the hybridized orbital. Only one molecule which is existing, which is called as your benzene, which is having a benzene ring is having a triple bond character. And all the carbon atoms over here is sp2 hybridized itself. So you have come to know that whenever you are having an ortho substituted part, dialkyl groups, halogen groups, what happens? They will be not giving you the Grignard reagent. But that is not the case in your meta and the para position. Is that clear? So that is the reason we have mentioned over here that these are the 6 villains you have to remember, where you should come to know that by whenever you are having such groups, they will not be able to give your respective Grignard reagent. It could be a allylic and a benzylic halides. If a compound is in the form of X, CH2, CH2 and an acidic group, I have mentioned what are those acidic group, alcoholic group, amine groups, or that of your carboxylic acid groups, SO3 H group. Okay, Similarly, when you're talking about your vinylic halides also we have seen, and coming with respect to 1,3 dihalides, or with respect to ortho substituted dihalides, or that of your structure of XCH2CH2 and a leaving group. So these are the 6 things you should keep in your mind whenever you have been given these structures. They will not be giving you any of the Grignard reagent. But for exam oriented, just you have to remember what do you mean by a Grignard reagent, how you're going to prepare it, and why we have to maintain a dry medium. Is that clear? So next we are going to give another important reaction which is called as Wurtz reaction. Wurtz reaction. See, basically here we are writing as a reaction. So it's a named reaction. So what does it say? So whenever we are talking about our alkyl halides, so when alkyl halides react with sodium metal, in a dry ether, here also we are maintaining the dry ether itself as a solvent. So basically we are going to get a higher alkenes. So this reaction is called as our Wurtz reaction. So generally how can we write? Of course we require an alkyl halide which will be 2 moles plus that of in the presence of a sodium metal in the presence of a dry ether. What happens? You are going to get as RR plus NaX, 2NaX. So this is a general reaction. For example, if I choose CH3Cl plus, you are going to get as 2Na in the presence of dry ether. You are going to get as what? Yes, CH3 plus 2NaCl. So you can just see why we have said as a higher alkenes. So here it was just like a methyl chloride, methyl chloride, where we are having just one carbon atom. But when you are seeing the product, what you are going to get? You are having the 2 carbon atoms. So it is from methane to it has been converted to that of your ethane. So it has been converted from methyl to that of your ethane. So what has happened? So major important property what we are seeing in the Wurtz reaction is this reaction increases the carbon length. That is what you can say, it is increasing the number of the carbon atoms in a molecule. So this could be an important example for a reaction which involves in the increasing of the carbon chain. For 1 carbon we can make it as a 2 carbon, 2 carbons we can make it as a 4 carbons. So this is the reason we can employ this reaction for the preparation of a higher alkenes by utilizing our smaller alkenes groups. But the major important thing we have to note over here in a Wurtz reaction, what is that? Remember, tertiary groups, what I can say, your tertiary halides do not undergo this Wurtz reaction. Once again, an important thing one has to remember for your competitive exams. What is that? Your tertiary halides will not undergo that of your Wurtz reaction. Why is it so? In order to understand it, first we have to understand it's slightly a mechanism. So what happens is whenever you're talking about taking the mechanism, your alkyl halide, first it reacts with that of your sodium metal. First it will be giving you in this way, R minus and Na plus plus NaX. Okay, 2Na. If I'm going to choose. So next what happens, since one more Na is, that is your R minus Na is there, what it will do, R minus Na plus, once again it is going to react with the reactant which is present. So what at that moment what you're going to get? You're going to get as an RR, that is this minus is going to attack our alkyl group, and then once again you're going to get as NaX. So this is the overall reaction where our 2Na is also balanced. Wow. So again, what we are seeing over here, when your alkyl halide is reacted with a sodium, first that alkyl halide will be having a negative charge on it. And utilizing that negative charge on the alkyl group, once again it is going to react with that of your reactant to give our higher alkenes. So when I am choosing certain tertiary halides, CH3, CH3, CH3 and an X if I choose. So if I'm going to write as a Na, the mechanism itself, instead of R, I have chosen a tertiary alkyl halide. So first what you are going to get, CH3, CH3, CH3. Here you'll be having as a minus Na plus NaX. So this negative charge is present. Now what it will try to do, CH3, CH3, CH3 minus, which is present, Na plus. It will now react with one more molecule of your reactant. So how it would be, CH3, CH3, CH3 and an X. So actually what it should have done, it should have conquered another R group. Alva, it has to substitute it. But instead of substitution, what happens, since now this is also an what? Electron rich species, and whatever here we are seeing, this group has to come. It is also surrounded with what? An electron donating groups. So what happens? Mutual repulsion takes place. So when I was explaining the bulkier nucleophile, what it can act as, when I was giving as a note in my previous videos, your bulkier nucleophile will be acting as a base. So instead of undergoing a substitution reaction, now what it will try to do, this part now acts as a base. That is, it will try to abstract the proton and it will be forming an alkene. That is, you'll be going to get, instead of merging these two, now what it will try to do, it will try to take one of the proton. That is CH3, 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 CH plus. Here what happens, one proton has gone. So in order to balance this, what it will try to do, it will form an CH2 double bond CH3, CH3. Are you able to see? So like this, instead of giving the higher alkanes, what it is trying to do, whatever the tertiary part you have obtained, it will be acting as a bulkier nucleophile. So whenever such a bulkier nucleophile is there, instead of undergoing a substitution reaction, it will be acting as undergoing an elimination reaction to give our alkenes. So that is the reason we are saying as what an important note, tertiary halides do not undergo the Wurtz reaction. And why is it so? We have seen in the mechanism. So in today's video, we have mainly dealt with the two important reactions, with the reaction with the metal, which includes your Grignard formation of your Grignard reagents. That is, whenever you are treating your alkyl halide with the magnesium powder in the dry ether. I repeat, in the dry ether, you are going to get as the alkyl magnesium halide, which itself is called as what? Grignard reagent. Why we are using as a dry ether? The dry medium is very much important because if any source of proton is present in the reaction system, whatever the alkyl magnesium halide, that is your Grignard reagent, has been prepared, it will be giving you the corresponding hydrocarbon. That is the reason we have to maintain a dry medium. Coming with respect to the Wurtz reaction, we have seen that whenever your alkyl halides are treated with the sodium metal in the presence of dry ether, we are going to get a higher alkenes. So that reaction is called as a Wurtz reaction. And the major important noteworthy point there also, we have seen that your tertiary alkyl halides will not be undergoing your Wurtz reaction. And the main reason is what? Because instead of undergoing that reaction, it undergoes an elimination reaction to give our respective alkenes. So this is somewhat whatever I have mentioned now as a final protocol, that was only related to your example. Of course, we have seen certain additional information. Make it as a note. It will be very helpful.